Good morning, students. So in this class we will discuss a relationship between radius of atom. We already know the radius of atom, metal or ion, it is represented as r, and edge length of unit cell, and the edge length of the unit cell is denoted by small letter a. So it means that in this class we will discuss the relationship between radius of metal or ion and edge length of the unit cell in the different types of unit cells. Majorly this relationship we will discuss for simple cubic unit cell, which is also called as primitive unit cell, and body centered cubic unit cell, it is represented as BCC unit cell, and face centered cubic unit cell, and it is represented as FCC unit cell. So this FCC unit cell, it is also called as CCP or HCP arrangement antu kuda karitare. In the various unit cells, so we will discuss the relationship between radius of the atom as well as edge length of unit cell. So in that, first we will take for simple cubic unit cell or primitive unit cell, that is relationship between radius of atom and edge length for the type of the unit cell, that is for simple cubic unit cell. For simple cubic unit cell or this simple cubic unit cell, it is also called as what in heading primitive unit cell. Primitive unit cell. Okay. So correct ಆಗಿ ತಾವೇನಾದರೂ ಪ್ಯಾಕಿಂಗ್ ಎಫಿಷಿಯನ್ಸಿ ಡೆರಿವೇಷನ್ಸ್ ಅಬ್ಸರ್ವ್ ಮಾಡಿದ್ರೆ ಅಂತಂದ್ರೆ ದಿಸ್ ಈಸ್ ನಥಿಂಗ್. ಇದನ್ನು ಆಲ್ರೆಡಿ ನೀವು ಅಲ್ಲಿ ಡಿಸ್ಕಷನ್ ಮಾಡಿದ್ದೀರಿ. ಸೊ ರೇಡಿಯಸ್ which is represented as r, that is the radius of the each particle is represented as r, and the edge length of the unit cell, all the three edges are represented as a. So in the simple cube, in the BCC as well as FCC, we already discussed calculation of packing efficiency. Therefore this you will feel like a revision only. Therefore now we will discuss relationship between radius of atom and edge length for simple cubic unit cell or for primitive unit cell. So simple cubic unit cell, for that I will draw one more time simple cubic unit cell. This is simple cube or simple cubic unit cell. So you already know that in the simple cubic unit cell, the constituent particles are present only at 8 corners. So instead of representing constituent particles at 8 corners, here I will represent constituent particles only at any 2 corners. Yavadada 2 corners. This is a corner particle and this is also corner particle, or here also you can represent this is one corner and this is one more corner. Just to avoid confusion, here I will consider only 2 corner particles to show the relationship between edge length as well as radius of the atom. So this is corner particle. So for this corner particle I will represent one constituent particle. Correct. So and this is one more corner particle. Here I will represent one more constituent particle. See, these two are the corner particles. ಇಲ್ಲಿ ಯಾವ ರೀತಿ ರಿಪ್ರೆಸೆಂಟ್ ಮಾಡಬೇಕಂತಂದ್ರೆ both particles should touch each other. ಎರಡು ಪಾರ್ಟಿಕಲ್ ಒಂದಕ್ಕೊಂದು ಟಚ್ ಆಗಿರಬೇಕು. ಆ ರೀತಿ we have to represent. So we have to represent the constituent particle. This is the first constituent particle with respect to this corner, and this is one more constituent particle with respect to this corner, and the distance from the center of nucleus to outermost shell, that is called as radius, and it is denoted as r. So this is radius of this atom, that is atom 1, and here also the distance from the center of nucleus to outermost shell, this is called as radius, and which is represented as r. Therefore this is the radius of an atom with respect to this corner, or this is the radius of particle with respect to atom 1, and this is the radius of particle with respect to second atom, and entire this distance or this length is called as what enanta karitare, that is the distance between two constituent particles in a crystal structures is called as edge length, and it is represented as or denoted as a anta representation ಮಾಡ್ತೀರಿ. Edge length of the unit cell, so this is one edge, correct, this edge is called as edge length, and it is denoted as a, or here also this is an edge of the unit cell, so this is called as edge length, and which is denoted as a. This is one more edge of the unit cell, this is called as edge length, and it is denoted as a anta representation ಮಾಡ್ತೀರಿ. So here just we will consider two corner particles, and for those two corner particles we will represent radius of each particle, and here we will consider one edge of the unit cell, and the edge of the unit cell is represented as edge length, and which is denoted as a anta denote ಮಾಡ್ತೀರಿ, a anta representation ಮಾಡ್ತೀರಿ. Therefore based upon this relation we can give the relationship between radius of particle as well as edge length of the unit cell. Here what you can observe, what conclusion you can draw from this diagram, a equals to ಏನಿದೆ, so this is the entire distance which is called as edge length, that is represented as a, and this edge length which is equals to the sum of the radius of both particle, this is particle 1 and this is second particle. Therefore edge length a equals to ಏನಾಗ್ತದೆ ಹೇಳ್ರಿ, r plus r. Therefore edge length a equals to ಏನಾಗುತ್ತೆ 2r. Therefore the relationship between edge length of the unit cell a and radius of the particle r in a case of simple cubic unit cell or for the primitive unit cell, what is the relationship? A equals to 2r ಅಂತ ಅರ್ಥ. ಇದನ್ನು ಕೂಡ ತಾವು ನೆನಪಲ್ಲಿ ಇಟ್ಕೋಬೇಕು. ದ ರಿಲೇಶನ್ಶಿಪ್ ಬಿಟ್ವೀನ್ ಎಡ್ಜ್ ಲೆಂತ್ ಆಫ್ ದ ಯೂನಿಟ್ ಸೆಲ್ ಅಂಡ್ ರೇಡಿಯಸ್ ಆಫ್ ದ ಪಾರ್ಟಿಕಲ್ ಫಾರ್ ಸಿಂಪಲ್ ಕ್ಯೂಬಿಕ್ ಯೂನಿಟ್ ಸೆಲ್ ಆರ್ ಫಾರ್ ದ ಪ್ರಿಮಿಟಿವ್ ಯೂನಿಟ್ ಸೆಲ್, ದ ರಿಲೇಶನ್ಶಿಪ್ ಈಸ್ ಎ ಈಕ್ವಲ್ಸ್ ಟು ಎಸ್ ವಾಟ್ ಏನಂತ ಅರ್ಥ 2r ಅಂತ ಅರ್ಥ. ಸಿಮಿಲರ್ಲಿ ವಿ ವಿಲ್ discuss for FCC unit cell, that is the relationship between edge length A and the radius of the particle R for what type of unit cell? For face centered cubic unit cell, that is for FCC unit cell. ಹೌದಲ್ವಾ, ಪ್ಯಾಕಿಂಗ್ ಎಫಿಷಿಯನ್ಸಿ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡುವಾಗ ಫಾರ್ ದ ಸಿಂಪಲ್ ಕ್ಯೂಬಿಕ್ ಯೂನಿಟ್ಸ್ ಅಲ್ಲಿ ಇದು ಟರ್ಮ್ ಆಲ್ರೆಡಿ ಬಂದೋಗಿದೆ. ಇದುವರೆಗೂ ತಾವು ಆಲ್ರೆಡಿ ಡೆರಿವೇಷನ್ ಮಾಡಿದ್ದಾದ್ಮೇಲೆ ನೆಕ್ಸ್ಟ್ ತಾವು ಪ್ಯಾಕಿಂಗ್ ಎಫಿಷಿಯನ್ಸಿದಲ್ಲಿ ದ ವ್ಯಾಲ್ಯೂ ಆಫ್ ದ ಎಡ್ಜ್ ಲೆಂತ್, ದಟ್ ಈಸ್ ಟೋಟಲ್ ವ್ಯಾಲ್ಯೂಮ್ ಆಫ್ ದ ಯೂನಿಟ್ಸ್ ಅಲ್ಲಿ ಎ ಕ್ಯೂಬ್, ಅಲ್ಲಿ ದ ವ್ಯಾಲ್ಯೂ ಆಫ್ ದ ಎ ಯು ಸಬ್ಸ್ಟಿಟ್ಯೂಟೆಡ್ ಆಸ್ 2r. Similarly we will discuss for face centered cubic unit cell, that is relationship between radius of atom and edge length of the unit cell for FCC unit cell. So for FCC unit cell, that is in FCC unit cell the constituent particles are present at 8 corners. In addition to 8 corners, the particles are also present center of all 6 faces, that I will represent one more time. Clear? This is cube. So in this cube, so in case of FCC unit cell, the particles are present at 8 corners. 1, 2, 3, 4, 5, 6, 7, 8. ಈ 8 ಕಾರ್ನರ್ಸ್ ಜೊತೆಗೆ the constituent particles which are also present center of all 6 faces. This is face 1. This is left side ದಲ್ಲಿರತಕ್ಕಂಥದ್ದು ಎರಡನೇ ಫೇಸ್, above ಮೂರನೇ ಪ್ಲೇಸ್ ಫೇಸ್, below ನಾಲ್ಕನೇ ಫೇಸ್ ದಿಸ್ ಎಂಟೈರ್ ಸ್ಕ್ವೇರ್ ಬಾಕ್ಸ್ ಕಾಣಿಸುತ್ತೆ ಅಲ್ಲ, ಅದರಲ್ಲಿ ಒಂದು ಫೇಸ್, ಐದನೇದು ದಿಸ್ ಒನ್ ಎಂಟೈರ್ ಸ್ಕ್ವೇರ್ ಬಾಕ್ಸ್ ಕಾಣಿಸುತ್ತೆ ಅಲ್ಲ, ಇನ್ ದ್ಯಾಟ್ ಒನ್ ಮೋರ್ ಫೇಸ್. ಟೋಟಲಿ ಫಾರ್ ಕ್ಯೂಬ್ದಲ್ಲಿ ಎಷ್ಟು ಫೇಸಸ್ ಇರುತ್ತೆ ಅಂತಂದ್ರೆ 6 ಫೇಸಸ್ ಇರುತ್ತೆ. ಇನ್ ಕೇಸ್ ಆಫ್ FCC unit cell, the particles which are also present center of all 6 faces. Here I will consider any one face to give the relationship between edge length and radius. For convenient, I will consider this is one face. So in case of FCC unit cell, the constituent particles are present at 8 corners. In addition to 8 corners, the particles are also present center of all 6 faces. This is one face. The constituent particle which is also present center of one face, and also the constituent particles are also present so all 8 corners. This is corner particle, this is face center particle, and here it is one more corner particle. Here also we have to represent one more corner particle. Clear? So this is corner particle, this is face center particle, and this is also corner particle. So here the distance between center of the nucleus to outermost cell, this is called as radius of atom, which is represented as r. For this face center atom, we will get value of r equals to r plus r, that is we will get 2r. Here again the distance from the center of nucleus to outermost cell with respect to this corner atom, which is denoted as r. So therefore we will join all these radius of the particles. ಇವು ಮೂರನ್ನು ಜಾಯಿನ್ ಮಾಡೋಣ ಅಂತ. Okay, and here we will represent all these edges as A, this is B, and this is C. So here this is represented as radius of atom 1, and here this is the center of the nucleus, this is radius r, and this is radius r. That is for the face center atom, the value of radius equals to we will get 2r. Again here the radius of the atom will get r. Therefore totally face diagonal value ಏನಾಗುತ್ತೆ ಹೇಳ್ರಿ, r plus r plus r plus r. Therefore face diagonal value, that is AC equals to ಎಷ್ಟು ಬರುತ್ತೆ, will get 4r, and this distance, this length is called as edge length, and which is represented as A ಅಂತ representation ಮಾಡ್ತೀವಿ. This is also edge length of the unit cell, and it is denoted as A ಅಂತ ಡಿನೋಟ್ ಮಾಡ್ತೀವಿ. ಸೊ ಹಿಯರ್ ವಿ ಕ್ಯಾನ್ ಅಬ್ಸರ್ವ್ ಒನ್ ಟ್ರಯಾಂಗಲ್. ನೀವು ನೀಟಾಗಿ ಡಯಾಗ್ರಾಮ್ ತೆಗೆದ್ರೆ ಟ್ರಯಾಂಗಲ್ ರೂಪದಲ್ಲಿ ಕಾಣಿಸುತ್ತೆ. ಸೊ ಮೇ ಬಿ ಸೊ ಇಲ್ಲಿ ಒಂದು ಸ್ವಲ್ಪ ಅಷ್ಟೇ ಟ್ರಯಾಂಗಲ್ ರೂಪದಲ್ಲಿ ಕಾಣದೇನೂ ಕೂಡ ಇರ್ಬೋದು. ಸೊ ಕನ್ಸಿಡರ್ ಟ್ರಯಾಂಗಲ್ ಎ ಬಿ ಸಿ. ಇನ್ ದಿಸ್ ಟ್ರಯಾಂಗಲ್ ಎ ಬಿ ಸಿ, ಸೊ ವಿಲ್ ಗೆಟ್ ಎ ಸಿ ಸ್ಕ್ವೇರ್ ಈಕ್ವಲ್ಸ್ ಟು ಎ ಬಿ ಸ್ಕ್ವೇರ್ ಪ್ಲಸ್ ಬಿ ಸಿ ಸ್ಕ್ವೇರ್. ಯಾವ ಆಧಾರದ ಮ್ಯಾಗ ಹೇಳ್ರಿ, ಅಕಾರ್ಡಿಂಗ್ ಟು ದ Pythagoras theorem. So according to the Pythagoras theorem, if you apply Pythagoras theorem for this triangle ABC, so according to the Pythagoras theorem, AC square equals to AB square plus BC square. That will apply to get the relationship between edge length A as well as radius R. Therefore, in triangle ABC, according to the Pythagoras theorem, we have AC square equals to AB square plus BC square. AC square equals to AB square plus BC square. What is the value of AB? AB ಏನಿದೆ ನೋಡ್ರಿ, that is edge length, which is denoted as A. AB square ಇರೋದ್ರಿಂದ ಏನಾಗುತ್ತೆ, this is A square plus BC, this is edge length of the unit cell, and which is represented as A ಅಂತ representation ಮಾಡ್ತೀವಿ. BC square ಇರೋದ್ರಿಂದ which is represented as A square. Therefore we will get AC square equals to ಏನಾಗುತ್ತೆ, 2A square. Correct. What is the value of AC? This is face diagonal. AC equals to ಏನಿದೆ ಇಲ್ಲಿ, AC equals to R plus R plus R plus R, that is 4R. AC square ಇರೋದ್ರಿಂದ this is 4R square. 4R square equals to 2A square, or 4R equals to ಏನಾಗುತ್ತೆ, root 2 into A, or on rearrangement the value of A equals to what you will get, 4R divided by root 2. Therefore value of A equals to 4R by root 2. This 4R by root 2, which is also written as 2 root 2 into R anta ಬರೆಯಬಹುದು. Therefore value of A equals to 2 root 2 into R. The value of the A equals to 2 root 2 into R. ನೋಡಿ ಕಾಣಿಸ್ಲಿಕ್ಕೆ ನೀಟಾಗಿ ಬರೀ. Therefore, A equals to 2 root 2 into R. Okay, this is the relationship between edge length A and the radius of an atom for what type of unit cell? For FCC unit cell. So in this diagram, see, in this diagram here we can observe a triangle ABC. So in this triangle ABC, according to the Pythagoras theorem, AC square equals to AB square plus BC square. The value of AB, which is called as edge length, and it is denoted as A. AB square than the A square. Adhe riti BC is the edge length and it is denoted as A. BC square than the A square. Therefore, AC square equals to A square plus A square. Therefore, we will get 2A square. Value of AC equals to 4R. So, AC square than this is 4R square, which is equals to 2 square. Idinella simplification madadre finally we will get A equals to 4R by root 2. This 4R by root 2, which is also written as 2 root 2 into R. ಇದನ್ನು ಯಾವ ರೀತಿ ಬರೀಬೇಕು ಅನ್ನೋದನ್ನು ಪ್ಯಾಕಿಂಗ್ ಎಫಿಷಿಯನ್ಸಿ ಆಫ್ FCC ಯೂನಿಟ್ ಸೆಲ್ ಅಲ್ಲಿ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡೋದ್ರಲ್ಲಿ ತೋರಿಸಿದ್ದೀನಿ, ಯಾವ ರೀತಿ ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿ ಬರೀಬೇಕು ಅನ್ನೋದನ್ನು. ಗೊತ್ತಾಗಲಿಕ್ಕೆ ಯು ಕ್ಯಾನ್ ವಾಚ್ ದ್ಯಾಟ್ ವಿಡಿಯೋ ಒನ್ ಮೋರ್ ಟೈಮ್. Therefore, this is the relationship between edge length of the unit cell and radius of the atom for FCC unit cell. Similarly, you can give the relationship between edge length as well as radius of atom for BCC unit cell. So, we will discuss for BCC unit cell. Third one, for body centered cubic unit cell for BCC unit cell. So, in BCC unit cell, the constituent particles are present at 8 corners. In addition to 8 corners, one of the constituent particle is present at the center of the body. Therefore, here we have to represent, in addition to 8 corners, we have to represent one body center atom. So, we will draw a diagram. Okay, so this is a center of the body and these are the corner particles. Therefore, in a BCC unit cell, the constituent particles are present at 8 corners. In addition to 8 corners, one of the constituent particle which is present at the center of the body. This is center of the body. In addition to body center, the particles are also present at 8 corners. This is one corner and this is one more corner. Clear? These two are the corner atoms and this is body center atom. So, we will join all these 3 atoms. Okay. So, here we will represent, this is A, this is B, this is C, this is D, this is E and this is F. Idana F anta representation ಮಾಡಿ. This is represented as F. This is A, B, C, D, E, F and this is G and this is H. ಅಥವಾ ನಿಮಗೆ ಏನಾದರೂ ಪ್ಯಾಕಿಂಗ್ ಎಫಿಷಿಯನ್ಸಿ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡುವಾಗ ಇದನ್ನು ಎ ಅಂತ ರಿಪ್ರೆಸೆಂಟೇಷನ್ ಮಾಡಿದ್ದು ನಿಮ್ಗೆ ಕನ್ಫ್ಯೂಷನ್ ಆಗ್ತಿದ್ರೆ, ಸೊ ಯು ಕ್ಯಾನ್ ರಿಪ್ರೆಸೆಂಟ್ ದಿಸ್ ಇಸ್ ಅಗೇನ್ ಎ ಅಂತ ಕೂಡ ರಿಪ್ರೆಸೆಂಟೇಷನ್ ಮಾಡೋದು. ದಿಸ್ ಇಸ್ ಎ, ಅದನ್ನು ಎ ಅಂತ ರಿಪ್ರೆಸೆಂಟೇಷನ್ ಮಾಡಿದ್ರೆ ಸೊ ದಿಸ್ ಯು ಕ್ಯಾನ್ ರಿಪ್ರೆಸೆಂಟ್ ಆಸ್ ಬಿ ಅಂತ ರಿಪ್ರೆಸೆಂಟೇಷನ್ ಮಾಡಬಹುದು. ಸಪೋಸ್ ನಿಮಗೆ ಏನಾದರೂ ಕನ್ಫ್ಯೂಷನ್ ಆಗ್ತಿತ್ತು ಅಂತಂದರೆ, ಬಿಕಾಸ್ ವೈಲ್ ಡಿರೈವಿಂಗ್ ದ ಪ್ಯಾಕಿಂಗ್ ಎಫಿಷಿಯನ್ಸಿ ಇನ್ BCC ಯೂನಿಟ್ ಸೆಲ್, ಈ ಇಲ್ಲಿರ್ತಕ್ಕಂಥ ಈ ಎಡ್ಜಲ್ಲಿರ್ತಕ್ಕಂಥ ಪಾರ್ಟಿಕಲನ್ನು ಇ ಅಂತ ರಿಪ್ರೆಸೆಂಟೇಷನ್ ಮಾಡಿದ್ದೇನೆ. ದೇರ್ಫೋರ್ ಟು ಅವಾಯ್ಡ್ ದ ಕನ್ಫ್ಯೂಷನ್, ಬೆಟರ್ ಯು ರಿಪ್ರೆಸೆಂಟ್ with a letter A only. So, for this BCC unit cell, we have to give the relationship between edge length of the unit cell as well as radius of the unit cell. So, this is called as edge length and which is denoted as A. this is also edge length and which is denoted as A. This is the distance between these two particles. This is called as edge length and it is denoted as A anta representation ಮಾಡಬಹುದು. So here observe a triangle AFD. In this triangle AFD, so apply a Pythagoras theorem. Again you will get AF square equals to FD square plus AD square. What is the value of AF? AF equals to, this is R, this is 2R and this is R. Therefore again we will get body diagonal, that is value of AF equals to ಎಷ್ಟು ಬರುತ್ತೆ, that is we will get 4R. Therefore in triangle AFD, AF square which is equals to AF square equals to FD square plus this is FD square plus AD square, FD square plus AD square, FD square plus AD square. What is FD? This is FD. Again this is a face diagonal with respect to this triangle EFD. In the triangle EFD, so FD square which is equals to EF square plus AD square. Note again in triangle EFD, so FD square which is equals to, in the triangle EFD, FD square which is equals to EF square plus ED square, EF square plus ED square. Therefore what is EF? EF is edge length which is denoted as A and ED is also edge length which is denoted as A. Therefore A square plus A square ಆದರೆ ಏನಾಗುತ್ತೆ, therefore we will get 2A square, that is value of FD square equals to, we will get 2A square. Therefore FD square equals to 2A square and ED equals to edge length and which is denoted as A, therefore it is again A square. Therefore AF square equals to, we will get 3A square. What is AF? That is body diagonal, the value which is equals to 4R. Hence AF square irodrinda this is 4R square equals to 3A square or 4R equals to root 3 into A. Since we got the, we have to derive the relationship between edge length and radius. Therefore on rearranging, the value of A equals to, we will get 4R divided by root 3. Therefore edge length A equals to 4R by root 3. To find the value of EFD, again we have to consider one more triangle, that is EFD. In this triangle EFD, FD square which is equals to EF square plus ED square. EF ಅಂತಂದ್ರೆ ಕೂಡ edge length A and ED is also edge length A. Therefore EF square ಅಂತಂದ್ರೆ A square, ED square that is equals to A square. Therefore A square plus A square equals to ಏನಾಗುತ್ತೆ, we will get 2A square. Therefore value of FD square equals to, we will get 2A square. Therefore again in a triangle AFD, AF square equals to EFD square plus AD square according to the Pythagoras theorem. Therefore AF square equals to, we will get a 3A square. The value of AF, that is equals to the body diagonal, its value equals to 4R. Therefore 4R square equals to 3A square. Ella simplification ಮಾಡಿದಾಗ we will get A equals to 4R by root 3 ಅಂತ ಬರ್ತದೆ. So this is the relationship between edge length of the unit cell A as well as edge length of the unit cell A and the radius of particle or radius of atom or radius of metal or radius of ion, that is equals to R. You ಮೂರು ಫಾರ್ಮುಲಾ ತಾವು ನೆನಪಲ್ಲಿ ಇಟ್ಕೋಬೇಕು, ವೆರಿ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್ ಫ್ರಮ್ ದ ಪಾಯಿಂಟ್ ಆಫ್ ಬೋರ್ಡ್ ಆಸ್ ವೆಲ್ ಆಸ್ CET. ಸೊ ಅಲ್ಲಿ ಏನಾದರೂ ರೇಡಿಯಸ್ ಕೊಟ್ಟು ಎಡ್ಜ್ ಲೆಂತ್ ಫೈಂಡ್ ಔಟ್ ಮಾಡಕ್ಕೆ ಕೇಳಿದ್ರೆ ಯು ಹ್ಯಾವ್ ಟು ಯೂಸ್ ದ ರಿಲೇಷನ್ಶಿಪ್ ಫಾರ್ ದ ಡಿಫ್ರೆಂಟ್ ಟೈಪ್ಸ್ ಆಫ್ ಯೂನಿಟ್ಸ್ ಅಲ್ಲ, ಅಥವಾ ಎಡ್ಜ್ ಲೆಂತ್ ಕೊಟ್ಟು ರೇಡಿಯಸ್ ಫೈಂಡ್ ಔಟ್ ಮಾಡೋರಂತಾದರೂ ಕೇಳ್ಬೋದು. ಸೊ ಇನ್ ದೀಸ್ ಟು, ಸೊ ಎಡ್ಜ್ ಲೆಂತ್ ಆ್ಯಂಡ್ ರೇಡಿಯಸ್ ಯಾವುದಾದ್ರು ಒಂದು ಪ್ಯಾರಾಮೀಟರ್ ಕೊಟ್ಟು ಇನ್ನೊಂದು ಪ್ಯಾರಾಮೀಟರ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಕ್ಕೆ ಹೇಳಿದ್ರು ಅಂತಂದ್ರೆ ಬೈ ನೋಯಿಂಗ್ ದೀಸ್ 3 ಫಾರ್ಮುಲಾಸ್, ಸೊ ಈಸಿಲಿ ಯು ಕ್ಯಾನ್ ಕ್ಯಾಲ್ಕುಲೇಟ್. So what is the relationship between edge length and radius R for primitive unit cell or for the simple cubic unit cell, that is primitive or simple cubic unit cell, the relationship between edge length and radius A equals to n ಹೇಳ್ರಿ 2R. ಅದೇ ರೀತಿ for BCC unit cell or for the BCC unit cell, therefore edge length and radius R which is equals to A equals to ಏನಾಗುತ್ತೆ 4R by root 3. ಅದೇ ರೀತಿ For third one, that is for FCC unit cell or hexagonal closed packing or cubic closed packing, CCP unit cell, the relationship between edge length and radius r, A equals to ಏನಾಗುತ್ತೆ 2 root 2 into r. Therefore, these three are the relationship between edge length and radius of the particle in various types of unit cells. ಅಗೇನ್ ನೀವೇನೋ ಇಷ್ಟು ಅಗೇನ್ ಡೆರಿವೇಷನ್ ಮಾಡೋದು ಅವಶ್ಯಕತೆ ಇಲ್ಲ, ತಮಗೆ ಇನ್ನೊಂದು ಸಲ ಗೊತ್ತಾಗಲಿ ಅಂತ ನಾನು ಈ ರೀತಿ ಡೆರೈವ್ ಮಾಡಿದ್ದೀನಿ. ಸೊ ಯು ಕ್ಯಾನ್ ರಿಮೆಂಬರ್, ಯು ಕ್ಯಾನ್ ನೋಟ್ ಡೌನ್ ಓನ್ಲಿ ಆಲ್ ದೀಸ್ ತ್ರೀ ಫಾರ್ಮುಲಾಸ್. ಇವು ಮೂರು ಫಾರ್ಮುಲಾನ ನೋಟ್ ಡೌನ್ ಮಾಡ್ಕೊಂಡ್ರೆ ಸಾಕು, ಈ ಮೂರು ಇಕ್ವೇಷನ್ಸನ್ನು ಬರ್ಕೊಂಡ್ರೆ ಸಾಕು. ಫಾರ್ ದ ರಿಲೇಷನ್ಶಿಪ್ ಬಿಟ್ವೀನ್ ರೇಡಿಯಸ್ ಆಫ್ ಆಟಮ್ ಆ್ಯಂಡ್ ಎಡ್ಜ್ ಲೆಂತ್ ಆಫ್ ದ ಯೂನಿಟ್ ಸೆಲ್ ಅಂತ ಬರೋದು. ಸೊ ನೋಟ್ ಅಂತ ಹಾಕಿ, ಫಾರ್ ಪ್ರಿಮಿಟಿವ್ ಯೂನಿಟ್ ಸೆಲ್ A equals to 2r, ಫಾರ್ BCC ಯೂನಿಟ್ ಸೆಲ್ A equals to 4r by root 3, for face centered cubic unit cell, so A equals to 2 root 2 into r. ಎಷ್ಟು ಈ ಮೂರು ಫಾರ್ಮುಲಾ ಗೊತ್ತಿದ್ರೆ by giving one parameter easily you can calculate one more parameter. ಇದ್ರ ಮೇಲೂ ಕೂಡ 2 ಮಾರ್ಕ್ಸಿಗೆ ಕ್ವಶನ್ ಕೇಳ್ಬೋದು. ಸೊ ಇನ್ ದ ಇಯರ್ ಆಫ್ ಮಾರ್ಚ್ 2014, ಮಾರ್ಚ್ 2014ರಲ್ಲಿ, ಸೊ ಇನ್ ಪಾರ್ಟ್ ಬಿ 2 ಮಾರ್ಕ್ಸಿಂದ ಒಂದು ಕ್ವಶನ್ ಕೇಳಿದ್ದಾರೆ. ಸೊ ದಟ್ ಈಸ್ ಫಾರ್ 2 ಮಾರ್ಕ್ಸಿಂದ ಒಂದು ಕ್ವಶನ್ ಕೇಳಿದ್ದಾರೆ ನೋಡಿರಿ. ಸೊ ಮಾರ್ಚ್ 2014ದಲ್ಲಿ ದಿಸ್ ಬೇಸ್ಡ್ ದ ನ್ಯೂಮರಿಕಲ್ ಈಸ್ ಆಸ್ಕ್ಡ್ ಬೇಸ್ಡ್ ಅಪಾನ್ ದ ರಿಲೇಷನ್ಶಿಪ್ ಬಿಟ್ವೀನ್ ರೇಡಿಯಸ್ ಆಫ್ ಮೆಟಲ್ ಆರ್ ಆ್ಯಂಡ್ ಎಡ್ಜ್ ಲೆಂತ್ ಆಫ್ ದ ಯೂನಿಟ್ ಸೆಲ್ ಎ. ಇವು ಮೂರು ಕ್ಲಿಯರ್ ಆಯ್ತಾ? ಸೊ ದಿಸ್ ಈಸ್ ಫಾರ್ ಸಿಂಪಲ್ ಕ್ಯೂಬಿಕ್ ಯೂನಿಟ್ ಸೆಲ್, ದಿಸ್ ಈಸ್ ಫಾರ್ FCC ಯೂನಿಟ್ ಸೆಲ್ ಆ್ಯಂಡ್ ದ ರಿಲೇಷನ್ ಫಾರ್ BCC ಯೂನಿಟ್ ಸೆಲ್. ಕರೆಕ್ಟಾಗಿ ಪ್ಯಾಕಿಂಗ್ ಎಫಿಷಿಯನ್ಸಿ ಏನಾದರೂ ನೀವು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡೋದು ಕರೆಕ್ಟಾಗಿ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಮಾಡ್ಕೊಂಡಿದ್ರೆ ದಿಸ್ ಈಸ್ ನಥಿಂಗ್. ಸೊ ನೋಟ್ ಡೌನ್, ಯು ಹ್ಯಾವ್ ಟು ರಿಮೆಂಬರ್ ಆಲ್ ದೀಸ್ ತ್ರೀ ಫಾರ್ಮುಲಾಸ್ ವೆರಿ ಕರೆಕ್ಟ್ಲಿ, ಫಾರ್ ಪ್ರಿಮಿಟಿವ್ ಯೂನಿಟ್ ಸೆಲ್, ಫಾರ್ BCC ಯೂನಿಟ್ ಸೆಲ್ ಆಸ್ ವೆಲ್ ಆಸ್ ಫಾರ್ FCC ಯೂನಿಟ್ ಸೆಲ್. ಸಿಂಪಲ್ ನ್ಯೂಮರಿಕಲ್ ಪ್ರಾಬ್ಲಮ್ ವಿಚ್ ಈಸ್ ಆಲ್ರೆಡಿ ಆಸ್ಕ್ಡ್ ಇನ್ ದ ಮಾರ್ಚ್ 2014, ಮಾರ್ಚ್ 2014ರಲ್ಲಿ ಕೇಳಿದ್ದಾರೆ. ಗೋ ಥ್ರೂ ದ ಪ್ರಾಬ್ಲಮ್. ವಾಟ್ ಈಸ್ ಗಿವನ್? Aluminum crystallizes in an FCC structure, atomic radius of the metal is given 125 picometer. ಹಾಗಾದ್ರೆ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಎಡ್ಜ್ ಲೆಂತ್ ಆಫ್ ದ ಯೂನಿಟ್ ಸೆಲ್. ಕರೆಕ್ಟಾಗಿ ನೋಡ್ರಿ ಪ್ರಾಬ್ಲಮ್ ಏನು ಕೊಟ್ಟಿದ್ದಾರೆ. ಗೋ ಥ್ರೂ ದ ಪ್ರಾಬ್ಲಮ್. Aluminum crystallizes in an FCC structure, atomic radius of the metal is given, ಎಷ್ಟು ಕೊಟ್ಟಿದ್ದಾರೆ ವ್ಯಾಲ್ಯೂ? 125 picometer. ಫುಲ್ ಪಾಯಿಂಟ್. Calculate edge length of the unit cell. So what is the type of structure? What is the type of crystal structure given? FCC structure. So aluminum crystallizes in an FCC structure. Therefore the type of the structure, crystal structure or unit cell is FCC unit cell. Atomic radius of the metal aluminum is given, that is 125 picometer. ಹಾಗಾದ್ರೆ calculate edge length of the unit cell. What we have to calculate? We have to calculate edge length of the unit cell. Edge length is represented as A. What is given? ಏನು ಕೊಟ್ಟಿದ್ದಾರೆ ನೋಡ್ರಿ? The radius of the metal is given, ಎಷ್ಟು ಕೊಟ್ಟಿದ್ದಾರೆ? 125 picometer. The radius of the metal is given, which is equals to 125 picometer. It means that the value of R is given 125 picometer. The value of R is given, they asked to find out edge length of the unit cell. So for what type of crystal structure? For FCC crystal structure. ತಮ್ಮ ಕಣ್ಣು ಮುಂದೆ ಇದೆ ನೋಡ್ರಿ. The relationship between edge length A and radius of an atom for FCC unit cell, A equals to ಏನಿದೆ? 2 root 2 into R. 2 root 2 into R. A equals to 2 root 2 into R. Therefore, so you already know we have the relationship between edge length A and radius R. A equals to 2 root 2 into R. Therefore, A equals to 2 root 2 into 125. Therefore, A equals to 2 into the value of root 2. Root 2 equals to 1.414 into 125. ಇದನ್ನು ಸಿಂಪ್ಲಿಫಿಕೇಶನ್ ಮಾಡೋದು ಎಷ್ಟು ಬರ್ತದೆ ನೋಡ್ರಿ. Therefore, A equals to 2 into 1.414 into 125. 125 into 2 ಮಾಡಿದಾಗ you will get 125 into 2 are 250. 250 into 1.414. ಇದನ್ನೆಲ್ಲ ಸಿಂಪ್ಲಿಫಿಕೇಶನ್ ಮಾಡಿರಿ. Therefore 2 into 1.414 into 125. Therefore you will get 353.5. Therefore the value of edge length A equals to 353.5. Therefore, unit ಏನು ಬರುತ್ತಿರಲಿ at the length A equals to, therefore at the length A equals to 353.5. ಇಲ್ಲಿ ಏನಿದೆ, the radius is expressed in terms of picometer. Therefore, again the value of edge length you have to express in terms of picometer, or you can also convert into ಮೀಟರ್ಗೂ ಕೂಡ ಕನ್ವರ್ಟ್ ಮಾಡಿ ಬರ್ಬೋದು. 125 ಪಿಕೋಮೀಟರ್ ಅದನ್ನು ಮೀಟ್ರಿಗೆ ಕನ್ವರ್ಟ್ ಮಾಡಿದ್ರೆ r equals to 125 into 10 to the power minus 12 ಮೀಟರ್ ಆಗ್ತದೆ. Therefore, in the final answer edge length A equals to 353.5 into 10 to the power minus 12 meter. No need to convert the unit again. SI ಯೂನಿಟ್ಗೆ ಕನ್ವರ್ಟ್ ಮಾಡೋದ ಅವಶ್ಯಕತೆ ಇಲ್ಲ. ಮೀಟ್ರಿಗೆ ಆಗಲಿ ಅಥವಾ ಸೆಂಟಿಮೀಟ್ರಿಗೆ ಕನ್ವರ್ಟ್ ಮಾಡ್ತಾರೆ. ಆಲ್ರೆಡಿ ಅಟಾಮಿಕ್ ಸ್ಟ್ರಕ್ಚರ್ ಫಸ್ಟ್ ಇಯರ್ದಲ್ಲಿ ಕಲ್ತಿದ್ದೀರಲ್ಲ, ಇಂಟರ್ ಕನ್ವರ್ಷನ್ ಆಫ್ 1 ಯೂನಿಟ್ ಇಂಟು ಅನದರ್ ಯೂನಿಟ್. ಸೊ ಅಲ್ಲಿ ಏನು, ಸೊ ಪಿಕೋಮೀಟರ್ ಇದು ಮೀಟ್ರಿಗೆ ಕನ್ವರ್ಟ್ ಮಾಡಬೇಕಾಗಿತ್ತು, ವಿ ಹ್ಯಾವ್ ಟು ಮಲ್ಟಿಪ್ಲೈ ವಿತ್ 10 to the power minus 12. ಸೆಂಟಿಮೀಟರ್ ಅಥವಾ 10 to the power minus 10. ಗೊತ್ತಿಲ್ಲ ಫಸ್ಟ್ ಇಯರ್ ನೋಡ್ಸಿ ನಮ್ಮ ತೆಗೆದು ನೋಡ್ರಿ. Therefore, ನೋಡ್ರಿ, this is a so simple problem which is asked in the year of March 2014 for 2 marks. Aluminum crystallizes in an FCC structure. Atomic radius of the metal is given 125 picometer. ಹಾಗಾದ್ರೆ calculate the edge length of the unit cell ಅಂತ ಕೇಳಿದ್ದಾರೆ. So we have to calculate edge length A. Therefore, A equals to question mark. The value of radius is given, r equals to 125 picometer. For FCC structure, we have the relationship between edge length and radius, that is A equals to 2 root 2 into r. Therefore, A equals to 2 root 2 into r ಅಥವಾ 125 ಎಲ್ಲ ಸಿಂಪ್ಲಿಫಿಕೇಶನ್ ಮಾಡಿದಾಗ ಫೈನಲಿ ವಿಲ್ ಗೆಟ್ edge length A equals to 353.5 ಫೈನಲ್. ಸೊ ಯೂನಿಟ್ ಏನು ಬರೀಬೇಕಂತಂದ್ರೆ ರೇಡಿಯಸ್ ಈಸ್ ಎಕ್ಸ್ಪ್ರೆಸ್ ಇನ್ ಟರ್ಮ್ಸ್ ಆಫ್ ಪಿಕೋಮೀಟರ್. ದೇರ್ಫೋರ್ ದ ವ್ಯಾಲ್ಯೂ ಆಫ್ ಎಡ್ಜ್ ಲೆಂತ್ A equals to 350, ಕರೆಕ್ಟ್ ಹೋದ್ರೆ ಓಕೆ, 353.5 ಪಿಕೋಮೀಟರ್ ಬರ್ತದೆ. ಸೊ ಇನ್ ದಿಸ್ ಮ್ಯಾನರ್ ಬೇರೆ ಯಾವುದಾದ್ರೂ FCC ಬದಲಾಗಿ ಇಲ್ಲಿ ಸಿಂಪಲ್ ಕ್ಯೂಬ್ಗೆ ಆದರೂ ಕೇಳಬಹುದು ಅಥವಾ BCC ಯೂನಿಟ್. ಸಪೋಸ್ ಏನಾದ್ರು BCC ಸ್ಟ್ರಕ್ಚರ್ ಅಂತ ಕೇಳಿದ್ರಂತಂದ್ರೆ ಇಲ್ಲಿ ಯಾವ ಫಾರ್ಮುಲಾ ಯೂಸ್ ಮಾಡ್ತೀರಿ? ಸೊ ಅಲ್ಯೂಮಿನಿಯಂ ಕ್ರಿಸ್ಟಲೈಸಸ್ ಇನ್ FCC ಬದಲಾಗಿ BCC ಸ್ಟ್ರಕ್ಚರ್ ಅಂತ. FCC ಬದಲಾಗಿ BCC ಇದ್ರೆ ಹಿಯರ್ ವಾಟ್ ಯು ಫಾರ್ಮುಲಾ ವಿ ಹ್ಯಾವ್ ಟು ಯೂಸ್? Here A equals to 2 root 2 into r. ಅದರ ಬದಲಾಗಿ for BCC we have the relationship A equals to 4r by root 3. Therefore, A equals to 4r by root 3 ಈ ಫಾರ್ಮುಲಾದಲ್ಲಿ ಏನಾದ್ರು ವ್ಯಾಲ್ಯೂ ಆಫ್ r ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದ್ರೆ ಅಂತಂದ್ರೆ you will get for BCC unit cell. Since ಇಲ್ಲಿ FCC unit cell ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ, therefore we have to use this formula, that is the relationship between edge length A and radius r. Finally, on calculation you will get the value of edge length A equals to 353.5 picometers ಬರುತ್ತೆ. This is a today's session. Here we discussed two concepts, that is the relationship between radius and edge length for simple cubic unit cell or for the primitive unit cell, for BCC unit cell, for FCC unit cell. Based upon this discussion, we discussed one problem. So based upon the relationship with respect to the FCC structure. So this is one problem. Similarly, you can solve various types of problems. Just you have to remember all these three formulas. Correct? Okay. Thank you.